Right, so what we're going to be doing this morning is working with an LC Smith single barrel trap. And this gun was manufactured based on the serial number sometime around the 1930s. I restocked this gun, so I've got another video out there if you want to go through the reassembly of the receiver. I've got a video out there that will walk you through all that process. But in this case, what was happening was the sear simply wasn't holding. So on this particular gun, I've seen it actually referenced now when I go back and I look at some of the guns and they say needs some trigger work. So this could be a solution, or at least giving you an indication of what you're going to need to do to resolve the trigger. So from discharging when you shut the gun. So trying to depict what's going on, this being the hammer and this being the sear. In my case, what was happening was the hammer was catching right at the top of that sear. And as you shut the gun, what would happen is it would actually, there wasn't enough bite on the sear and the hammer would just release. So one area that you might know that you're trending in a direction to where you could have some trigger work is if the pull of the trigger starts getting below 3 pounds, 2 pounds in that area, it becomes real light. Chances are you just need to be aware of it, primarily for safety reasons. So when you're shutting the gun, obviously you're always going to have the gun pointed outwards. But with the voice automated pulls and maybe somebody standing next to you, depending on how they have their gun held, it's something to be aware of with these guns. That these not only the LC Smith. I'm not picking on this design. The Parkers like this, the Ithacas like this. These guns made back in the 1915s through the 1930s. They're very, very similar in terms of their trigger design. So what I was after was this sear is probably about 20 thousandths too short. What I'm after, if you'll notice in this diagram, I'm after the hammer catching about middle or further down from the top of this sear. And I want the sear to come up closer to the top of this hammer. Now you're probably going to end up with about a 4 pound, maybe 4 pound plus-ish trigger pull. But when you shut the gun, it's not going to discharge. So that's the objective. To give you an idea of the intended operation, I pulled this out of a book here. We'll talk about this in just a moment. I'll show you the book. But this is the LC Smith single barrel trap, and this is showing the hammer fully cocked and how the sear is coming in and holding down this hammer. Now on my gun, the hammer did not come back this far. It's actually coming back to maybe right about in there. So I don't know. You either have to make another hammer, which is a much more involved process, or you make the sear maybe just a little bit longer. I would encourage you to seek out a gunsmith and get their opinion on the best operation or best approach to maybe resolve this if your gun's discharging. But you definitely want to get it resolved. What I'm doing, all I wanted to do here was just sort of give you an idea of the specs. We'll get into the material and the hardening here in just a little bit, but these were some of the specs. The book that I have does not show the specs of the sear. That was missing. Sadly, you can't use the side-by-side sear on this. It's just a completely different sear design. I did search around from other sears. The Ithaca kind of comes close, but it's too short. So I just made another sear is what we're going to go through here. But these specs can give you a starting point maybe for what you're doing. Hopefully you've got the sear already, and what I would do is just copy. That's what I did. I just copied the existing sear and just made it a couple of changes in the design in terms of the thickness and so forth. But that's what I would start with. So this is just maybe a guide to help you get started with it. All right, so let's take a look at the sear. This is the original sear that came out of the gun when I bought it. And you notice, I don't know actually, you'll be able to notice here, but at the top of the sear you can see where, if I catch the light right, you can see just right on that front edge, it's just barely catching the top of this edge. So what would happen is if you shut the gun, there just wasn't enough bite, and the hammer would just go ahead and close, making it really very unsafe to use, and that ended that for me. So the process I went through is I used Starrett 497 air hardening, and I machined it out with the milling. Now this took about 2 to 3 hours from start to finish. This part of it wasn't, but maybe 15, 20 minutes. But this is the roughness. Now, if you were more skilled on a milling machine, I would have taken a lot of this excess away. The milling machine is not something I spend a lot of time on. Buddy of mine let me use his. So for those that are familiar with machining, I get it. Laugh out loud. I'm sure you're having a great time watching this. But for the person that's not familiar with the milling machine, this is what I did. Now this thickness will actually come into play a little bit later, and we'll talk about that. I guess we'll talk about it now. What you're wanting to do is, if this is the screw that holds us in here, and what you're wanting to do is have this sear rotate freely. In my case, it was too thin, and that might be one of the things you can check, but what was happening was there's a little bit more play. We'll talk more about that. I'm jumping ahead here on this. But anyway, back to the sear. So this is what we did. We machined it out, milled out this middle area. You want to check your specs there, and then that's what I did there. The next step was what I did was I grinded it down to fit. Now you'll notice pretty quickly some of the differences here. First of all, I made this a lot thicker. And that really hasn't anything to do so much with the bite, but you can see here, my bite is actually lower. It's actually catching right about here, where the top of my pencil lead is. The reason why that's moved away is that's where it's sliding through. So it's actually catching right below that shiny spot, which is significantly better because on this one it was catching right at the top edge of that. So now when I shut this gun, it does not go off. So I've got lots of good. That worked out very well for me. So now I can shoot the gun. All right. So let's talk a little bit about the material and the hardening process, because ultimately what you're going to need to do is you're going to need to have that material hardened. This is another area that somebody with some more experience might find this amusing or be able to add additional insight into it. But anyway, on this particular material, it's a 497. The temperature that you want to get up to is about 1750 to 1800. On the internet, there are some pictures of what the temperature of the material would look, the color of the material or the metal, what it would look like. The best way I can describe it is a Texas sunset. It's sort of a blood red, sort of a blood reddish color, and that's about 1750. Again, I don't have a calibrated oven to walk this through the entire temperature, but on this particular material for that hardness, again, off the internet you can get some of these temperatures, or you can call Starrett. They're very helpful. You're looking for 5 to 10 minutes at that temperature to get that hardness. Now, in it being that this is very, very thin, it's nowhere near what I did, and this will be somewhat of an experimental process, trial and error. I went for 2 minutes at a blood red on this to get that hardened. The next step that you're going to do is you're going to draw that out or temper the steel. And the way I did that, according to Starrett, they got 2 different their hardnesses on here. 350 to 400 for 2 hours gets you at 6062, or if you went to 1100 for 2 hours, you're at 4852. Now, in that, what I did was I went at 375 for 2 hours. So I'm probably more directionally closer to the 6062. Now, this is that book that I was talking about that I found. It's the Plans and Specifications of LC Smith, and it was made by Lieutenant Colonel William S. Brophy. This gun has virtually all the blueprints of the gun. There are a few parts that are missing, like for example on the sear, they don't have a spec on the particular sear. So I would encourage you, if you can find this book, I would get that book, because it goes through and it tells you a whole lot of information. You probably could just about manufacture this gun. On page 205, what's important is it goes through the sear, the temperature, hardness, and the drawing it out. So you've got the sear at 1675, which is pretty close to what Starrett had. They wanted at 375 for 1 hour, and they're at about a 44 to 52 hardness. Now all they reference in here is a chrome vanadium steel. Now this is where the trial and error comes into play, because the 497 does have some chromium in it. It's as close as I could come up with. There's 399 there's other steels that you could come up with. I would encourage you to research the steels, maybe even call Sterrett and get their opinion on it, to find another steel. Maybe the 497 for my purposes is going to work. This is not going to be one of my competition guns, but I'm absolutely going to go out and shoot this gun. But so once you do that, then probably go ahead and get it milled out, and you may even want to take it to more of a professional hardening and tempering than what I did. But for my purposes, I think I'll be fine. I got what I was after. Like I said, my trigger is probably about a 4-pounder. Maybe that's a little light reference. It might be a tad bit more than that. But the main thing is when I shut that gun, I know it's not going to go off. And so anyway, so hopefully all this has been helpful. Probably missing a couple of things. Here's what I forgot to tell you, was this thickness here. Now on mine, I'm at 0.114 is where I'm at, 0.114. That actually is a little narrow. I needed actually, and what I did was I got this washer, and this adds me in at about 20 thousandths is what I needed for this. And all this does is it sort of holds this in here a little bit better. Otherwise it can wiggle. So one of the things, the point in this, one of the things that I would check is if your sear, and I did take the spring out of here, so this is spring loaded in here, so I went ahead and took the spring out. But if your sear's in here and you feel that it wobbles in here when you take that spring out and it wobbles in there, you might be able to resolve the error by putting in a washer. And what I did was I put the washer on the outside of it. The mistake I made really when I was milling this, what I should have done was left it a little thick and then grind it on this end to get the exact dimensions. What you're after again is trying to make sure that you get a good tight fit on the screw, but it's still only allowing it to swivel. And I just got lucky, to tell you the truth. I added 20 thousandths to that screw, and that got me right where I needed to be. All right, so other than that, I don't know of anything else I could say. I wish you the luck on this. It's actually a lot of fun to go through this process. Like I said, you're looking at 2 to 3 hours. For me, for somebody that's better experienced on a milling machine, you probably could have taken an hour and a half off of that or even more. I don't work with milling machines on a regular basis, so I went for grinding. Anyway, that's it, and wish you the best.